Now let us see what happens when the compiler runs the program private override. So the compiler comes here, and then because there is public static void main, it enters to the function here. Okay. Now it will come to this new derived. Here we are creating the object for derived class. So the compiler goes to the derived class because of the keyword extends to private class. It goes to the f function. At this f function, the compiler notices that this is a private function, which means this function is the final one. Because of this one, this will be considered final, and then it simply takes this program and then comes out. Once it comes out, it will check the derived class. Here there is overriding of f function using public, but we know this is a private function. So this function will not at all considered, goes back to here and executes the line pivot.f. Because f is here, the compiler goes to private void f function, enters inside and prints the statement private f. Okay, and the program will end. So please keep in mind, if the function is private, this itself is a final function. A private function cannot be overloaded. Similarly, let us look at the static methods. What happens if we have static methods? This one we have already covered in the polymorphism one, which we discussed in the previous lecture. But anyway, let us discuss one more time. Here we have a class mother with static function and a non-static function. Next, we have a child class which extends mother. Now when we execute this program, static polymorphism, the Java compiler enters here, visits the main function, and then comes here. Mother, child equivalent to new child. So the compiler goes here, enters into mother. Because there are no constructors or global variables, the compiler enters into the child. And since there are no constructors in the child class, it exists from the child class and assigns the created object to the mother. Once that has been done, it will visit the next line which says child dot static get. We know that static means we only keep the latest one. So when we call it, we enter here and then we check the word static. But we already have the word extends. So the function will go to mother, enters into the static, prints the return statement mother static get, and then comes back. And when we say child or dynamic get, the Java compiler enters into the child and sees this is dynamic get is not a static class, so it simply enters inside and prints child dynamic get function and completes the program. So this is how the compiler behaves. So here is the text. A static method is not related to the object. The static method is always related to the class. So once the compiler enters into the parent and sees the static function, this will be taken. Okay? Because we are using mother. If you have difficulty in understanding the concept, I try to give a good example. Okay? We have left hand side, we have right hand side. If a method you are calling is a static method, go to the left hand side method. Okay? Choose the class which is on the left hand side. If it is a non-static method, okay, visit the function of the right hand side. Okay, so let me redo the things. Static, okay, non-static. Now here we are saying child static get. So static get. If you look at the static get function, this is a static function. So what we do is we will not enter into this function. Instead, static, right? So we choose the mother, that is left hand side, enters in, prints the value, and then come out. Very simple. Okay. If you are calling a static function, always choose the left hand side one. Now when you say child dot dynamic get, this function dynamic get is not a static function. Thus, the compiler chooses the right hand side, enters in to this function, prints child dynamically and comes out. Okay. So just keep that in mind. Static means choose the class of the parent. If it is not a static function, choose the right hand side. That will help you in understanding. Let us look at a much complex program of how the system calls will be done. Watch carefully. We have meal, bread, cheese, lettuce as the base classes. They are the base classes. Next, we have lunch and portable lunch classes, okay, which are not base classes but they are inheriting from the base classes meal and lunch respectively. Now here we are creating a class called public class. sandwich extends portable lunch. In this class, we are creating the objects for bread, cheese, and lettuce. And we have the constructor followed by the main. Now let us see how the compiler moves. The compiler comes first here because it has a main function. Okay, it will first enter into the main function, goes down and creates a new instance or object for sandwich. So from here the compiler goes to the constructor sandwich and then it will check whether I can go inside the sandwich or is there anything that is extending this class. We can see that the class sandwich extends portable lunch. Thus, instead of going down, the compiler goes to portable lunch class and comes here. Now, once it comes, it looks at extends lunch. So it will not even enter here. It will go to lunch. Lunch extends meal. So it will not enter into the class. Instead, it will go out and enter the class meal. The class meal has no extents. So it will enter into the constructor meal and then prints the statement meal here. So this statement has been done. Now constructor will return back. How the constructor will return back? It will finish the class, comes in the same way as it came. Okay. From meal it visited the meal. Now it found lunch. Now it enters into the class lunch, enters into the constructor lunch and prints the statement lunch. Once this is done, the compiler comes back, enters into the portable lunch, the constructor prints the statement portable lunch and exits. Once it exists, it will visit the global variables or global objects bread. So here bread is there. So goes into the class bread, prints bread, comes back, takes cheese, enters into the cheese, prints cheese. Similarly, the next one is lettuce. So it will print the lettuce and finally it will enter into the constructor public sandwich executes the statement sandwich. Prints it here. Okay. So this is how the compiler movement will happen if we have many constructors. Please try to use the markers to see how the compiler is moving. Only by doing so, you can able to understand the order of the output. If you simply try to do the things by visually, you may incur errors. So please always use the pencil or something and move it. I try to cover this topic one more time. Please watch it. I am taking the compiler here. First one is it is enter Java compiler is entering here. Okay. It will not go inside because the Java compiler has to create the instance of this class first. So it enters into the void main. It came here. Okay. So here we are creating a new object for sandwich. So at this step, what happens is the compiler goes to the class sandwich. Sandwich has extends portable lunch. Okay. So what happens is it will visit the portable lunch. It will not go inside. Instead, it will enter into the parent class lunch. From there, it enters into the main. Since there is no extents, it enters through the constructor, executes the statement meal, prints it here, and then it comes out. Once it is done, we know that meal was called by the class lunch. So it comes down to the lunch, enters into the constructor, prints the statement lunch. Once this is done, the compiler comes out of the lunch class, goes to the subclass portable, enters to the constructor, prints the statement portable lunch. With this, okay, extents is finished. So now there is nothing there to stop the entry of the compiler into the Java class. So now the Java compiler will come down. Because these are global variables or global objects, first they will be executed before the constructor. So this line will bring the bread here. Next line will print cheese. The third line will print lettuce. Once these things were done, then the compiler will visit the constructor, prints the sandwich at the end, and then terminates. This is how the constructor will move. Hope you all understood the movement of the constructor. The philosophical question in the Java programming is which one to follow first. Okay, because in the real world, we have objects that have has a and is a relationship. Okay. Some researchers say that has a is better to start and then build with easier. Okay, means use first construct a human body, okay, by combining eyes, head, legs, and so on. Once you create a body, then use easier relationship to create clones. And some others say that use easier as the better one. Okay? But the thing is, there is no correct solution to start your project. Okay? The real world is very complex. So please use your knowledge and programming skills to dynamically choose which one to first solve, as a or is a problem. Later you try to continue. Now we are at the end of this presentation, where we are going to look at the other topics other than polymorphism. These topics are not included in the Java course. However, I plan to discuss them because of their importance. For example, if you go and do research in the field of data science or information retrieval, you will be often used to work on these regular expressions, lambda functions, and so on. So, thinking your future applications in the perspective, I want to cover these four topics. Let us start with regular expressions. A regular expression is a sequence of characters that form a search pattern. Okay, we often use regular expressions to identify particular words, replace them or split them, so on and so forth. These are the common usages of regular expressions. Regular expressions are not inbuilt in the Java program. Okay, so you have to import the package called regex, which is in the utilities subpackage. In regular expression, there are three types of classes. The first one is pattern class. In the pattern class, you define what kind of a pattern you are trying to search. Whether you are trying to search integers, whether you are trying to search strings, you are trying to search some special characters. Those definitions you will first mention in the pattern class. Next, you use the matcher class. As you can see, matcher means it tries to match the given pattern in the former class. Okay, and then you can check whether there are any errors or not using pattern syntax exception. Okay, so we have these three classes in regular expressions. Don't worry, let us see with an example of how we use regular expressions. Here is the code. So the objective of this program is, given a sequence of words or sentences, identify whether there is a word with W3 schools. So we have a public class function main. For this main, we have the public static void main function, where we are first defining the pattern. So when we are defining the pattern, we are saying pattern.compile search for the word W3 schools. So this is the word to search. And this is case insensitive, means if the word is in capital letters or in small letters, do not care. If it exists in any case, identify it. Okay. So this is our keyword. Next, we are giving the keyword to search in a sequence of words. Here the matcher we are giving it as a string. Instead you can read a file and check. Okay, so the matcher will take this line and check whether this line has the word W3 schools. If the matcher finds this word, then it returns the boolean true or false. In this case, okay, both are one and the same because we are choosing case insensitive. So we get the value true. So the compiler comes inside and prints output as match found and then exits. If there is no such keyword in the given text, it says match not found. Okay. And this line pattern dot case insensitive. This is called flag in regular expression. This will tell what kind of search method we have to follow. Flags I want to cover in depth because they are very frequently used in the real world. The first one is pattern dot case insensitive. Okay, means whether it's a capital letter or a small letter, I don't care. That is case insensitive. Next, we have literals. Means if we have special characters like star, okay, and so on, we can use the word pattern dot literal. The last and the final one is pattern dot unicode case. This we try to use if our data set has non-English characters. Okay. When I was in India, I was often using English text. So I often use only these two pattern flags. I never used it. So I thought this is useless. But when I started working on Java and in particular the Japanese tweets, okay, which are basically in Unicode, these two will not work. So at that time, I have to use this Unicode case to identify the keywords that the Japanese use, like Jishin and all, and try to perform the analysis on the earthquakes. Now we can use some specialized concepts for pattern matching. The first one is braces. Okay. So when we use the braces, it means find one character from the options between the braces. Means if I say in the braces A, B, C, if the given string has A or B or C, okay, it will say yes, a letter exists. Similarly, if I use the word caret above, it means the keyword should not exist. Then 0 to 9 means the characters must exist between 0 to 9. Similarly, we have meta characters where we can use the pipe symbol to represent R. Means assume I am giving a sentence. I have dog in house. Okay. Now you want to find whether my sentence has cat or dog. We give like this. Then the pattern matcher will check whether this word has either cat or dog and tries to identify. Similarly, there are many meta characters that we can use. Okay. So please check them. Next, we have quantifiers, means whether we can use only one or multiple or non-occurrence is also fine. That we define using the quantifiers. For instance, if I use the word n plus, what it means is it matches any string that contains at least one n. Okay. If I use the word n plus, it means a given text should contain at least one n. If I put the word star, it means the given string may or may not contain n. It is fine for me. That is the meaning. Okay. Similarly, we have other ones. You can check it. Once we complete the regular expressions, the important ones are lambda expressions. Lambda expressions are lambda functions. They are quite useful, especially in Python. These lambda functions are extensively used, and I plan to cover it in this course for Java. So what is a lambda function or a lambda expression? It is a short block of code which takes in parameters and returns a value. Okay, a function we all know. A lambda expression is very little of a function. Okay, it is generally written in one line, and then we call it. That's why we call it lambda expression. The main difference between a function and a lambda expression is that lambda expressions do not have name. Okay, and they are implemented in the body itself. So here are some syntax of how to use a lambda expression. So you can give a parameter to a lambda expression and it will be completed. You can also pass multiple parameters to a lambda expression. Okay. If you want to input multiple parameters, please use braces and the order of passing these parameters. As I told you, generally expression is confined to one line or very small piece of a text. If you want to add a code block, you can add the code block using parentheses. Okay, within the parentheses you can write much bigger lines and it will be working. Let us look at a small example how the lambda function works. Okay, so here I am creating the main class. In the main class I have a void main function. In this function I am creating an array list integers. Since this is an array list, I don't need to specify the size of an array. Okay. And for in this array list numbers, I am adding the values 5, 9, 8, 1. Okay. Now I want to print the elements in this array list numbers. How do you print it? Generally, what you have to do is you have to first take it into a list and then traversal the list and you have to print it, which is a very difficult and a time taking process. Instead, what you can do is you can simply take the number and create a lambda expression. So what we are saying here is for numbers dot for each means for each element in the number. Okay, I am calling the number as n. Okay, take the value and print it here. That's it. So this will automatically print 5, 9, 8, 1. This is the advantage. If you want to print the elements in the array and all, we can do in this way. Here we are simply printing the output. If we want the output of a lambda expression can be stored in a variable. In the next example, we will see how the output of a lambda function can be stored in a variable. So this class is same as the previous class. Okay, so we have main and from main we enter into void main function. Inside we are creating an array list number and we are adding the values 9, 5, 9, 8, 1. Once we did, what we are trying to do is we are taking the value n and printing it into the number. Okay. So here the value becomes 1, 2, 3, 4 like this. And these ones we are storing it in this consumer list, and this method is now passed into the numbers, and will print the value 5981 and so. This is how the lambdas are used. I hope you understood how we build the lambda. Now we look at how do we collect the memory consumed by the program. This is a very important one. Okay. Generally, as a students, you use too many input variables and so on. Creation of a variable takes time, takes memory, and takes energy also. So we should not create too many variables. Okay. Also, if we do not write the code optimally, we may run out of the available memory. So we always need to write the code optimally. So when we are writing the code, we often check how much memory our program is taking. For that, what you have to do is first create a final variable of size megabyte. Okay, this will capture the size of a megabyte. Once you have it, now call the function runtime. Okay, and using the runtime, use the garbage collector and clear the unused memory. Next, you calculate what was the total memory that was available to you and how much is the free memory available. Okay, like for example, I have 100 GB of memory. Okay, that is total memory is 100 GB. Out of this 100 GB, 20 GB is full. Okay. Now what is the free memory? 100 minus 20, right? So that we are collecting. This we are collecting it in bytes. So what we are trying to do is from byte, we are using the function bytes to megabytes and dividing it. And we are printing it in megabytes. This way we can measure the memory of our program. Similarly, we can also calculate the runtime. Okay. So for that, please keep in mind, when you are calculating the memory after the main function, the first line must always be the start time. Okay, in your program, if you are calculating the total memory consumed by your program, it should always be the first line. Start time is always the first line. Okay. Next, we will have the stop time. After your logic has been implemented, you check the stop time. Then do the difference and then print the difference time. If you see here, he is taking the difference and passing it into a long variable. You know, long variable itself takes lot of time. Okay. So this is a very wrong way. You can simply say stop minus stop. Okay, this is somewhat better, but you can make this program much better. Okay, please pause this video, take 5 minutes of time, see how you can make this program better. The way to make this program better is as follows. Use the word start time in the beginning. No problem. Now, to calculate the elapsed time, you don't need to create any variables. Okay? You simply say system.out.println system current time millis minus start time. That's it. This simple one line can give you the output. Okay, this will save two parameters. Okay, stop time, end time, so on and so forth. And it will be much faster. If you want, you can give it a try. Okay, so this is my last slide of today's video. If you liked our work, please press the like button and subscribe to our channel for more videos on this Java topic. Thank you.